Unified dynamics. Distinction theory.
In standard physics, a gap exists between our descriptions of light and matter. Light propagates at a constant maximum speed, while matter possesses rest mass and inertia, yet both occupy the same continuous space-time background. Unified dynamics approaches this by replacing the smooth background with a discrete combinatorial geometric substrate. This model discards the idea of distinct particles existing inside a separate vacuum. Within this network, physical properties are emergent consequences of how information is routed. A photon is defined here as a level 1 open geometric line. It represents a single distinction, an A to not A connection, without any topological closure. Because this line is open and does not loop back on itself, it requires zero computational processing time to exist on the network grid. This lack of processing delay forces the photon to move at the network's maximum operational limit. In this framework, mass is not an inherent ingredient added to the system. It is a structural state assumed by the same informational updates that form light. Matter occurs when that information incurs a severe topological penalty, physically slowing down its propagation through the discrete substrate. To categorize these structures, unified dynamics uses a geometric ladder that ranks configurations by their complexity. A mathematical point is level 0, and a basic line between points is level 1. The photon is a level 1 structure, a transfer of state between nodes with no interior volume. Volumetric closure requires geometry to loop and enclose space. As this line curls, the structural burden counter stays at 0 because the path never completes. A one-dimensional line lacks the mathematical components required to achieve that closure. Consequently, these open lines place no computational weight on the surrounding network. These unburdened updates are classified as ghost updates. The localized calculation cost for a ghost update is 0. The network architecture processes this information instantaneously, moving the state from node to node without any queuing or processing delay. What we observe as the speed of light is the unitary speed limit of a network moving information without topological friction. However, these massless updates do not always remain isolated. The network has a native geometric attraction, the Einstein coupling, or kappa. This value creates localized potential wells that warp the straight-line paths of the ghost updates. This attraction curves the paths of massless lines, drawing them towards a shared center. As multiple lines are pulled into the same region, they begin to overlap and cluster. We track these clusters by their element count. As the count rises from 1 to 6, the tangled lines vibrate rapidly but fail to lock into a structure, remaining transient noise. Stability requires a threshold of 7 elements. Because a stable tetrahedron is composed of 6 edges, a 7th element, a master distinction bit, is needed to lock those edges into a self-referential fixed point. Crossing this threshold is the prerequisite for forming a permanent physical structure. When the cluster hits the 7th element, the tangled lines snap into a rigid geometric tetrahedron. This is the K4 tetrahedron, the smallest possible 3-dimensional closure. It represents the first stable, closed geometry that can exist within the substrate. This event, simplicial barogenesis, is the point where massless noise condenses into matter. Maintaining this closed K4 structure requires a different level of computational work. The network ledger now registers a processing cost. Because it is a closed volume, the network must recursively calculate its state to prevent it from dissolving. Inertia is the physical experience of this processing delay. As the structure moves, it drags against the network, constantly calculating its existence. This computational drag permanently anchors the structure, preventing it from ever reaching the speed of light again. Matter is the macroscopic measurement of a localized topological traffic jam. In a macroscopic view of the lattice, we see an ecosystem of varied structural complexity. Frictionless lines dart around the dense, slow-moving clusters of tetrahedral matter. The speed of light is the baseline update speed for information that carries 0 topological burden. Matter is computational noise that has crossed the n=7 threshold and become trapped in a closed geometric loop. Standard models treat light and matter as distinct excitations in separate fields. In this framework, light and matter are identical updates that differ only in their degree of simplicial closure. The transition follows a logical progression. A line reaches closure, that closure locks into a tetrahedron, and that tetrahedron manifests as mass. Matter is light permanently frozen into geometry.